Alright, young people, so hopefully you have already tried these yesterday, and so now you're just going to get some clarification on whether you did the right thing or where you could have possibly gone wrong. So please try these before you look at this video. Okay, it's 2 questions, but there's multiple parts. I'm also going to go over how these are graded. Okay, let's do question number 1. So we got Ruth riding her bicycle on a straight trail, and we get the velocity. So again, ding ding ding. If we want distance, we need to integrate this. If we want acceleration, we need to derive that, take the derivative of it. Okay, so that should automatically. In miles per hour, for the selected value between 0 to 2.4 hours. Okay, noticing your units are hours at this point. We want to know, or we're given that her velocity is always positive. Okay, so that's important. Okay, use the data in the table to approximate Ruth's acceleration at a time of t equals 1.4. So we're approximating. This is important. For approximating, that means that we're not using derivative or anything like that. We're just taking an approximate. And if you notice, 1.4 is right in between here, right? Right in between here. So approximate in between these 2 points. That means we're just going to use basic slope. And again, the slope of velocity is acceleration, right? This is the slope or change in velocity. So we can just use basic slope here. Okay, so let's go ahead and start finding those y values. So it's going to be 16.3 minus 17.2 over 1.6 minus 1.2. This is basic slope. y2 minus y1 over x2 minus x1. Put that in your calculator. Magically, you should get negative 2.25. And don't forget to put your units, miles per hour squared. Boom. Okay, so that first part was a 2-point question. The first point was for having the correct value. The second point was for having the correct units. So units will matter on these. Units will matter. Now let's look at part B. Using the correct units, interpret the meaning of this integral. Again, integral means, integral velocity means distance. So your brain should already go, this is distance from 0 to 2.4. Then it says to approximate it using a Riemann sum. Okay, so let's first do let's go ahead and put what it is. So we're going to say that the integral from 0 to 2.4, this is going to be really hard to write, of v of t is, I'm just going to say it because I'm not trying to write a sentence, is the total distance Ruth traveled in miles from 0 to 2.4 hours, or from time is 0 to time is 2.4 hours. Okay, that's worth 1 point to write that sentence. Again, big parts are total distance, because that's what the integral symbol means. And we know that the distance is the integral of velocity, and then we got to say from time equals 0 hours to time equals 2.4 hours. Okay, so that's the first point from just interpreting it. Next, we want to do a Riemann sum. For Riemann sums, we just want to draw a graph. Oh, shizzle. Okay, we're going to do a Riemann sum. This is going to be tough. Might actually have to just do this in class. We're going to do the Riemann sum, and we want 3 intervals from 0 to 2.4. So what I'm going to do is I'm just going to come up here, and I'm going to actually start drawing these points, because these points are important. So from 0 to 2.4, if I wanted to cut this into 3 intervals, hopefully you can see that my 3 intervals would be from 0 to 2.4 would be 0.8 and 0.16 and 2.4. Right, let's see. So from 0 to 2.4, I have these. Each of these intervals is 0.8 in width. Does that maybe kind of make sense? Hopefully. Each of these intervals is 0.8 in length. 0.8 in length. Okay. So we need to go ahead and use. Excuse me. Those are kind of our guidelines. So 0.8, 0.8, 0.16, and the way that I drew these lines is kind of weird, but I'm just thinking of 2.4 and cutting it into 3 pieces, right? So 2.4 is the ending. Then if I wanted to cut it into 3 pieces, then I would cut it into 0.8 and 1.6. Okay, because from here I can make 3 bars. 1 bar, 2 bar, 3 bar. Now the important part is that it says the midpoint Riemann sum, so you're going to use the point that's in the middle of each interval. So I need the point at 0.4. So what is my height at 0.4? That is 11.8. 11.8 is that middle point. And then at the middle between 0.8 and 1.6 would be 1.2. Okay, so 1.2 it's 17.2. 17.2. There's that point, not drawn to scale. And then the middle point between 1.6 and 2.4 is going to be 2. So that middle point is going to be 12. Was that 20? I think 20 or 16.8. 16. So it's actually below. It's actually down here. 16.8. We'll say that's 16.8. Okay, so now you just draw bars, and then think of the area of those bars. So my first bar is 0.8 in width and 11.8 in height. My second bar is 0.8 in width also, but 17.2 in height, and I did a terrible job with these pictures. And then my last one is 0.8 in width also, but 16.8 in height. Okay, so I just find the area of each of those by the area of a rectangle, which is 0.8. So length times width, 0.8 times 11.8. That's going to give us, I had that written down somewhere. It gives us a number. I'm just going to write it all out here. So the total is 0.8 times 11.8 plus the area of the middle one, which is 0.8. The widths should all be the same, or else you mess something up. Times 17.2 plus 0.8 times the height of the last one, which was 16.8. So we'll probably do a poster of this in class today, just to just like the slope fields, kind of help you guys visualize it. And then that adds up to 36.64 miles. Alright, beautiful. So this is different. I think we've done left and right Riemann sums, but we haven't done midpoint. So we'll do a couple different ones in class today. Okay, let's just finish question number 1. So her velocity can be modeled by g of t equals, okay, so this is Ruth's velocity, and this is the same. Okay, so here's a function to match that table, basically. According to the model, okay, and it might not be exactly the same, but it's supposed to be following that path. What was her average velocity during the interval? So this is interesting. So what you want to do is take the total distance traveled divided by time, right? Because average velocity is distance over time. Well, we already said that the distance is an integral, so let's go ahead and say that it's going to be the integral of g from 0 to 2.4. That's how we find the distance. And then how much time has passed from 0 to 2.4? 2.4. Alright. I believe this one was the calculator allowed one, right? You would just substitute all that into the calculator because we don't want to do that nasty integration by ourselves. That'd be disgusting. And we get an answer. Our answer should come out to be, you can literally substitute this in the calculator except for g of t, right? All that nonsense. Okay, you should get 14.604 miles per hour. Okay, so you get 1 point for knowing that it's an integral, and then you get another point for actually having the right answer. Alright, beautiful. Last part of D. So according to this model, is her speed increasing or decreasing at time equals 1.3? So let's think about it. What tells us? Speed increasing or decreasing? This is a fancy way of saying the word acceleration. Okay, that's all that is. That's just acceleration. So acceleration is the derivative of velocity. So the derivative of velocity at time 1.3. That's what we're looking for. Okay, so we want to go ahead and find that value. Okay, so again, the calculator will take the derivative of this function up here for us, and then all we got to do is substitute in 1.3, or we could just tell it what's the derivative at a point. We could use that option. Okay, and we should get something like 3.76. Okay, but we have to remember that even though it's accelerating, the acceleration is positive. It matters whether it's speeding up or slowing down. So if its acceleration is positive, that means it's speeding up in the positive direction. So if it's already positive, then its speed is increasing, right? Because the speed has no direction. Okay. If we had a negative, this is speed. If we had a negative acceleration and we had a negative velocity, then it's also speed is increasing in the negative direction. So our velocity and our acceleration have to match for the speed to actually be increasing. Okay, so let's see what the velocity is at 1.3. If you put that in the calculator, that should give you 18-ish, right? So the speed is positive, the velocity is positive, and the acceleration is positive, which means it's going to be speeding up at that point. Okay, so a good explanation would be something like speed is increasing at time 1.3 because velocity and acceleration have the same sign at this point. You have to give a sentence for why. So basically it's always going to be the speed is increasing because the velocity and the acceleration have the same sign, the same direction. So if they didn't, then you would say it's not increasing because the velocity and the acceleration are of opposite signs or opposite directions. Alright, young people. We'll draw some posters today for Riemann sums. Sorry that I'm super nasally.